Welcome to the presentation of the project I have done for the course of Advanced Data Science with IBM in Coursera. So let's go. 18 for the project, I decided to use the volume forecast database that is in Kaggle, and the reason why it is using is because I want to develop my skills in forecasting using machine learning algorithm. So in this database, we can explore it. It's basically a database for a beer company. So where they have several features inside on it, we can quickly explore when they have the demography, what is the average of the population, the income. We have the calendar, that is basically the holidays, historical volume. It's what they are used to sell per agency, per product, in the different values that they have. It is the total industry sodas, the volume of the whole industry that is selling, the price and promotion that they have per agency, per product, and the weather condition that practically are part of the feature that we have in this database. So we explore it very quickly. So important to go in order to do initially how it is a very small database. I use my own computer, but even though it's better than the Watson with half of core on a core per hour. So in my laptop, so I just install the Python and Jupyter Notes. So let's go to start with the first, that is the ETL. In the ETL, so basically what we did is basically what we did to read all the CSV file that they provide, showed to see that they are, looking pretty well in the pandas, because I am putting all of this in a pandas data frame. So basically, so we read it, then we convert some, the dates are in a strange format, so I am converting all the dates to dates, formatting. Then I merge all the data sets that I have in the CSV to one single set data set where we can have all the information, the agency, the SKU, the year, month that is already in dates, the volume, the price, the sales, the promotion, the soda volume, the industrial volume, the holidays that they have, the average temperature, the average population, and the average income. It is what we have for the first one. Then for the second one, we go on to the second part when we start to extract the feature selection. For the feature selection, it is I use some special brute force in order to try to for the feature engineering. So we just have this file where it's the same. We import the libraries. We have the different models where what we are trying to use, because I will try to do evaluation of the feature importance based on the different algorithms that we have for machine learning. So just to try to select it, and also which are then feature the accuracy and error information that I want to use to evaluate the model. So we read this in the data sets. So we read the database, then we have the indexing separating the Y, there is the label, because it is a supervised model from the X, that is the volume. Then we made a correlation just to see what is the correlation, a heat map based on correlation, just to see which is the correlation in each factor. So for example, Christmas and sales, they have low correlation, and this one 23 this Labor Day with the volume, so the volume, so they have good correlationship. So it is the case where we don't have anything in the World Cup and Football Club, so we start to remove these two ones. And then I put here to identify which are the SKU with the more volume. So I have SQ1, 2, and 3 are the best. Then I made a get to dummy for the SKU just to separate the SKU as a dummy. So just to put in this part in order to use the algorithm that they want to use, this means, for example, this means that this value is related to SQ23, this row. Each row will have only one of this one. So after that, we use the standard scalar to avoid, to put everything in the same parameters in order to avoid the biggest features. It's the smaller one. For example, temperature also go in a range of 200 from 0 to 100, and but the volume could go to thousands or millions. So in this case, so we use a scalar to escalate all the information. So then I choose this good algorithm from a part. I convert in a function where basically what we will do is evaluate all the models at the same time, and just to get a matrix based on the different models, just to get the results to take the action that we want to get. This is also something that I get is just to plot the features in a fashion way. So running the function that we have before, so it's what I tell. So we have the different measurement, and we have the for different models. So in this case, we see the R squared for RF is the best. Normally, this when it's reached to 1, this is multiplied by 100. So I multiply by 100, so it is 96 is pretty good because it's near to 100. In the case, I also want to evaluate the RMSE because it is the value that are used for continuous data. So in the root mean square error that we have, the lowest that we have is this one, that is gradient boost, and it is good because it is must be 0. So while R squared is good when it's near to 1, RMSE is very good when it's near to 0. So in this case, it is what we have a very good value. So we just run it, the regressor, we see the feature importances, and we have all the feature importances that we have, checking that is the average population. So I run this first one for the random forest, that is the one with the higher R score. And then I run it with the gradient boosting regressor, that is the one that have the best RMSE, root mean square error. So this means I have the values of the sector. Also, we have SQ1, SQ3, and SQ2. Here we have SQ2, SQ3, and SQ1 plus average population, yearly house income, and promotion. So these are the values that I take. Then, while I just take these three features that are practically the volume, because volume is the Y, plus the SQ, the average match temperature, and the promotion. So here I plot the graphics, and it is what we have. Now, let's go to the next part, that is basically defining the model. In defining the model, so basically we have, again, we import the library that we need. We will use TensorFlow with Python in my computer because I know more about Python and TensorFlow than the Apache Spark. Something that I want to learn to use the Spark data frame, but this took me to 1 month to do it. So it's better to use what you know just to learn the new concept, and then you try to learn the another. So here we read the data set, we made this that we put in the past, that is basically to select the SQ1. So for the SQ1, so we want to define the model using this one is a function that I take from this tutorial from TensorFlow. It is pretty good if you want to learn more about series. So it is practically to put the series in a fashion way when I took 3 points, like some point as an input and other point as an output, just to get the supervised model. In my case, I use 3 as an input and 1 as an output. So this means the first 4 value, 3 are input and 2 are value. In the second, I have the second item, the third item, and the fourth item are the X value, and the 5 item is the Y value, and so on. So you can read it here just to try to understand what I did. I'll also try this plot train to try to plot the loss of the validation versus training set. It's pretty good because it's what I will use to try to choose my model. So here we have basically splitting the information. I have 60 data points. With this 60 data point, I will split 50 for training, 3 for validation. This goes to 53. One that we lost, that is the last one, because the last one will be a Y but not an X. And we have 6 for the test set. So I use a brute force practically. I use all of them and just select that is max apt scalar is the best for my model with the configuration that I put. So you have the option to try to test other ones, just you can see it. Then so we split, we made the data set that we needed, that is a multidimensional. They have 3-dimension data that basically is the volume, the average temperature, and the price. And then we have a split in training, validation, and test. And I start to run some models like a year room, get some results in this one. But basically, so I make also like a brute force for this case where I put to run many times, many models just to see which is the best. So I start to see this one that in the validation text is pretty good. And in the training set, in the test set is also acceptable, but I need to choose between R2 or RMSE. So I start to see different models that we put with different configuration. This is another error view, but I use a mean square error instead of mean average error that I used in the previous one. So you will see how I start to create models and models just to see which is the behavior. Okay, this is another with LSTM using mine. Then another, you see the graphic of the validation loss and versus training loss. This is the graphic for the GPredict using the test set. And so you start to see it's a constant just to repeat the model with different configuration, with different until I get some of them that could be valid. I choose for after evaluate all of the, I choose to use one of this model that is the one that have, if I remember, this one that have a dropout open for the LSTM with 300 node, 200, 150, and using mean square errors as a function log with add-on optimizer. It is what I choose. The rational, okay, the validation and training loss is very good. And then when I go to the validation of the test, so I have a very good RMSE. So I am checking this one even in the R2 score is bad, so I feel comfortable with this one. But I taste more just to see, so you can see the whole data and try to run it by yourself just to check it. So this is your task. Then I have the last one where I put try and evaluating one in one part for the demand planning. I put everything. What I did is just again, just put it this one, read the data set. Then I analyze SQ01 with the function that I have, with the model that I select, that is the, remember, which drop out open for mean square error. So I do again with the validation test is okay with, in this case, with the, when I run the model again, so they have less value in the RMSE, a higher value in the RMSE, but it's still acceptable. But then I analyze the SQ02. I have in a day used to a very good model again in terms of the run mean square error. And then in the SQ3, so I am using the same model, so I have a very good result also with the RMSE. It is more or less what I did in order to try to implement all the knowledge that we took during the course. I hope you have enjoyed the project, and thank you for taking the time to watch the video. Bye.